Is there a missing planet? Let's start by setting the distance from Saturn to the Sun as 100 units. Mercury would then be around 4 units. Venus would be 4 plus 3. Earth would be 4 plus 6. Mars would be 4 plus 12. Can you see the pattern here? The numbers double each time. Following this pattern, the next distance should be 4 plus 24. But oddly, there's nothing here. Further out, Jupiter is 4 plus 48, Saturn is 4 plus 96, and they all fit the pattern perfectly. So why is there a gap in this segment? Astronomers centuries ago were baffled by this. Where did the missing planet go? Actually, the fascinating pattern we just saw later became known as the Titius-Bode law. It was first observed in 1766 by the German astronomer Titius, who noticed this pattern in the distances of planets. He casually wrote it in a book's footnote. A few years later, another astronomer, Bode, read it, found it intriguing, and decided to organize it into a formula for publication. Thus, this pattern was named after both of them. Though the formula seemed rough, its results closely matched actual observations, with the only exception being the gap between Mars and Jupiter. At the time, astronomers widely believed that there was clearly a planet yet to be discovered in this gap. But how would they find it? To search for the missing planet, astronomers embarked on an unprecedented observation frenzy. During this time, a German amateur astronomer, William Herschel, quietly entered the stage of history. On the surface, he was a musician, but his true passion was astronomy. He built his own large telescope and spent 7 years observing the night sky. One night in 1781, while mapping the stars, he accidentally discovered a faint little dot of light. This light was so dim, there was no record showing any celestial body in that spot. Though Herschel initially thought it was a comet, he was puzzled that it didn't have a comet's tail. This discovery gave him a strange feeling that something was unusual. Herschel soon realized that this mysterious object might not just be an ordinary comet. So he invited other astronomers to calculate its orbit, and the result shocked everyone. This was a planet that had never been discovered before. It was the first time in human history that a new planet was confirmed directly through a telescope. However, when Herschel proposed naming the planet after King George III of England, it met with strong opposition from other countries. In the end, the astronomical community chose a simpler name, Uranus. Herschel's discovery not only shocked the scientific world, but it also led astronomers to reassess the potential of the Titius-Bode law. By calculating the orbit of Uranus, they were astonished to find that the new planet's distance almost exactly matched the predictions of the law, with only a tiny error. This further boosted confidence in the law. Since the law successfully predicted the position of Uranus, it made the search for the missing planet between Mars and Jupiter even more worthwhile. Yet, finding it in the vast expanse of space still seemed like searching for a needle in a haystack. On New Year's night in 1801, Italian astronomer Giuseppe Piazzi was observing star positions when he unexpectedly noticed an extremely faint light. This light almost blended into the night sky, not shining brightly, and there was no unusual movement, but it caught Piazzi's attention. He tracked it for several days until it gradually disappeared from view. Although there wasn't enough data to confirm it, Piazzi had a strong feeling that this might be the key to filling the gap. His discovery was quite different from Herschel's experience. While Herschel had initially thought Uranus was a comet, Piazzi was quick to suspect that this faint light might hide something important. However, he didn't rush to publish his conclusion. Instead, he discussed it privately with a few friends, hinting that this object might be the missing planet between Mars and Jupiter. But to avoid unnecessary controversy, he publicly claimed that it might just be an ordinary comet. However, Piazzi knew deep down that he was probably on the verge of a major breakthrough. Piazzi's discovery soon caught the attention of other astronomers. By the end of 1801, this faint light was observed again through telescopes. Scientists calculated its orbit and discovered that it was exactly located between Mars and Jupiter. Excitement spread quickly, and it seemed they had found the missing planet. However, subsequent observations left them puzzled. The brightness of the object was so low that it didn't look like a typical planet. Although Piazzi initially estimated its diameter to be 2,000 kilometers, after further calculations, the result was revised to just 260 kilometers. Such a small object. Could it really be called a planet? Further observations revealed more mysteries. Although its orbital position matched the predictions of the Titius-Bode law, its size was unexpectedly small, with a diameter of only a few hundred kilometers, far below the size of any known planet. So, what exactly was this object? During the debate in March 1802, another similar small object was discovered and named Ceres. Soon after, Pallas and Juno were discovered as well. These discoveries led scientists to realize that the area between Mars and Jupiter wasn't home to a single planet, but rather a special region filled with countless small bodies. As more bodies were discovered, the true nature of this region began to emerge. It turned out that it wasn't the orbit of a single planet, but rather a cluster of small objects scattered throughout space. In 1845, the discovery of Vesta was made. In 1847, the existence of Hygeia was confirmed. The complexity of this region became apparent. As early as 1802, Herschel had coined the term asteroids to refer to these small objects. Since then, this region has been named the asteroid belt. With advances in observational technology, the number of asteroids recorded has increased year by year, and now millions have been documented. So, is the asteroid belt a remnant from the early solar system, or was there a planet that exploded for some reason? At this point, we still don't know. If it's a remnant from the early solar system, then the Titius-Bode law might just be a coincidence. But if it's the result of a planet exploding, then the Titius-Bode law is completely accurate. But this accuracy also leads to some unsettling thoughts. In any case, this discovery led humanity to uncover a brand new region in the solar system. And scientific exploration is never just about finding answers, but also about chasing those unexpected possibilities.